Our last talk of the night is Zaman. He's from Facebook. They created React. But he's here to talk about Flow. Do you guys know about Flow? It's like a way to type your properties in React. This title is courtesy of me. I wrote this title. Thank you. Okay, everyone give it up for Zaman. This is going to be awesome. Even better Flow.
Okay, kind of loud. I'll start by saying there were some really nice, pretty slides just before my talk, so I'm going to change everything. My slides only have code, nothing else but coding, so be ready for that. The title is slightly more advanced Flow. I'm going to be breezing through the basics and talk about the stuff that I see lots of people get tripped up on. Lots of this has been decided based on internal group chats, people inside Facebook are constantly asking questions about Flow and getting tripped up on these particular things too. So hopefully it'll help you. When I work at Facebook, I contributed to Flow, one commit or something. I did write some docs, so the current React and Redux docs. I wrote the first version of that because I wrote blog posts. And because I gave this talk, there's a link at the bottom that's more specific to using Flow with React and Redux. But most of this will apply there too. So, moving on. I'll start with the basics, talk about opaque types, which is a very new feature to Flow. It came out 2 versions ago, which is a month ago. There's property variants, which nobody understands for some reason. There's object types, because object types in Flow are huge. And then utility types is something that I've covered before. There's a whole page on the docs for it, but I'll just go through the basics if I have any time left. It might get nuts. So the basics. The basics are that Flow generally just adds one keyword to your syntax, which is type. It's like variable, but instead of being a variable, it's a type. You can define aliases, like I do here, which is type ID is equal to string. You can define object types, you can have higher kinded types like array of person, and you can have tuple types, which is an array with 2 things right there. Lots of people don't know about that, it's pretty useful sometimes. And this little pipe symbol is called a union type. You should read it like or, which is why I call it ID or person. If you've not used JavaScript types or functional language types, this might be a little weird, but if you just think of it in terms of, I need it to be a string or a number, or types make a lot of sense. Then there's functions. I'm guessing people usually know how functions are typed, so I'm not going into that specifically. I'm showing how generics work. So when you want to write a function types, a generically typed function, this is how you type it. You put little triangular brackets, which basically means for some type A and B, you don't know what those types are, this is the type of the function. So a map function takes some A and B, we don't know what that is, it takes an array of A. A mapper that takes A, converts it to B and gives you an array of B. Similarly with a fiddler function and then a flat map function. And if you've written a lot of JavaScript, you may know that the same function can often handle multiple different types. So a plus, imagine a function that just pluses 2 elements, it could have a type like this. So it's either a function that takes 2 numbers and returns a number, or it's a function that takes 2 strings and returns a string. But in this case, we don't use the or symbol, we use the and symbol, because the function is both of those types at the same time. It's not one of those types, it's both of those types. There's interfaces. Lots of people don't know that Flow has interfaces now, pretty similar to interfaces in every single language. And TypeScript, you just define an interface like this. You define a bunch of types in it. Some of these types could be functions. And then you can just say implements that interface, and Flow will check that you implemented the interface correctly. Enums. So Flow doesn't really have an enum keyword. TypeScript does, other things do. But you can still get all the benefits of enums with a little bit of extra typing. So let's say you have an enum of multiple strings. You just set up a type which is or of all the exact strings. And sometimes you want, the strings is the most common case, you have a particular list of strings that you want to use all over the place, but you also want variables. You don't want to just hard code those strings all the time. So this is a common case that you might do. You might like make an object, put all the strings as keys and values within that object, and then you can use this special $keys with the type of that variable to basically generate this type for you. I'll go to $keys again towards the end. It's a utility type that I mentioned in the agenda. Disjoint unions, this is a special case. If you use Redux, it's very useful. This is an example from Redux, like a simple counter method, where you say your action is one of these types, and flow, like as long as you have one key, which in this case is type, which always has specific values, in this case strings, then flow can decide when you check for the type key which particular type it is, and all the other keys will be type checked automatically. So if you want to read more about this, or see the slides on the other talk, goes in depth about this. Okay, that was the basics. I hope it's not going too fast. Like lots of the basics have been covered. It's pretty similar to TypeScript. These are opaque types. It's a very new feature to Flow, and I think it's very useful. So, what are opaque types? Opaque types are just types that you define in one file that are completely opaque in all other files. So, in this case, I'm defining that a URL is a string. This is a common problem in JavaScript. URLs are usually strings, but they're not all strings. There's some of the strings. So every URL is a string, but every string is not a URL. In an object-oriented language, you might make a class called URL that extends string, and then you might add a bunch of methods to it. It's a lot of boilerplate, stuff like that. With Flow and like functional languages in general, you can just say this is an opaque type called URL. It's the same thing as a string. And in the same file, you can add a bunch of helper functions, which is like, hey, get me a URL from a string. This will take a string and return a maybe URL, which is basically null or URL. And so in this function, you can like do a regex check and make sure it's a URL and return the string as is, otherwise return null. You can have other helper methods. But then when you're in a different file and you import this helper method and this type URL, you can't use URL just like that. Like if you have a string, which is like maybe URL, or like this string, you can't just pass that string to navigate. Like even though URL and string are the same type in the original file, you can't use them interchangeably anymore because as soon as you're out of the file, the type system doesn't know what URL is. It just knows it's some type, and unless something specifically converted it to the URL type, you can't use it like a URL type. So navigate is a function that takes a URL type. You can't give it a string. This will error out. But if you use the helper method that we defined in the same file to convert your string into a URL type, then you can use it. This is useful for all sorts of like validation checks, other kinds of things, mutation checks, things like that. Continuing on, you can have like checks like this, which is like, hey, does this URL contain the .com string in it? So right now I have to put this function in the same file where I define the type URL. Because if I try to define it in a different file and I use a .includes on .url, that also errors. Because Flow doesn't know that URL is a string or a string is a URL, like nothing, it knows nothing about URL, it's just a type. But sometimes you want the type system to know that, hey, a URL is always a string. A string may not be a URL, but every URL is a string. So there's a way to do that, which is just this. Like when you're defining a type the first time, you just say, hey, this type URL that I'm defining and exporting, it's a subtype of string. And now when you use it elsewhere, Flow knows that every URL is also a string, and this will be fine. There's a whole docs page about it. If you need more details about it, it's described pretty well. Type variants. This is the thing that most people get tripped up on, so I'll take the most time with this particular flow. This is not code. I said this is all code. This is more like math. This is more like definition of what type variance is. So assume you have some collection type C. Collection type can be like an array, a map, something like that. A type that uses another type in triangles, like that, right? And you have some type A and some type B. And A is a subtype of B. Let me give you an example. A is a cat, B is an animal. So a cat is a subtype of an animal. Then if CA is a subtype of CB as a result of this thing, then C is called covariant. which means like the type relationship flows in the same direction as the type that's used within the triangular brackets. If it flows in the opposite direction, you might have a hard time thinking of an example. The most common examples are functions and their arguments. They go the other way. Then it's called contravariant. You usually expect most of your collection types to be covariant. Most other languages have given you this habit. TypeScript does this by default. But in Flow, almost all the time they're invariant. I'll give you an example right next to it, which means that CA and CB would have no relationship whatsoever. It wouldn't flow in either direction. Let me show you why. So you have a class animal, you have a class dog, you have a class cat. And you have a variable dogs, which is an array of dogs. So far, so good. You expect to be able to do this line. You say, hey, array of dogs is an array of animals because every dog is an animal. However, this is not the case. And if you want to know why, like this little subtitle above gives it away, mutation ruins everything, it's because, let's say it was possible, you said animals, which is an array of animals, is now dogs. So you just put this variable in. And then on the next line you say, hey, animals, which is an array of animals, I can put any animal into it. You say animals.push cat. But both those variables were pointing to the same array, and array is mutable, so now suddenly your variable of dogs has a cat in it, and that's a type error. This is why Flow doesn't let you do this to begin with. This is why in Flow this line would error to begin with. But sometimes you want this behavior, and what's the problem? The problem is mutation. So you can fix that problem by just taking away mutation. So there's this special type in Flow called read-only array, which is the same type as array minus the mutating methods. It doesn't have .push, .pop, things like that. And if you use this type, if you make your animals variable read-only, then you can assign dogs to it. And now this line is fine, but this line is not, because the push method doesn't exist on read-only arrays. You can't mutate that variable. Read-only array, also very useful for Redux, because Redux wants immutability everywhere. The other talk talks about it, you can see that. So how do you make your own covariant classes? Like if you're making your own collection types, like a map, for example, you usually have like this little triangular brackets at the top. You're saying, I have a map of T's. You just put a little plus sign next to it, which means that your class will flow in the same direction as T. Just don't put any mutating methods in here. That would ruin it. And then you can also define another type right next to it, which would be like map T, which will extend your read-only version. And in this case, don't put the plus, and this will be invariant, and you're good to go. I haven't come up with any example that might be invariant, but if you do have an example which flows in the other direction, it's just a minus sign. Objects. Okay, hopefully I'm not going too fast. Objects. So this is a simple object type. A person has a name and an age. Name is a string, age is a number. So the little thing I'm starting with is something called lower and upper bounds. So there was a talk at, I think, React Europe, where they went deep into how Flow works internally. And essentially every flow type is two different types. The lower bound and the upper bound. How you should think about it is what's required and what you can use, right? So when you define a function and you're saying, like this type is person and it takes a type person, there's one set of types which is inside the function, which is if you have a variable of type person, how can you use it? That's like one side of the type system. But then there's another side which is what can you pass in that would satisfy this type. So in an object type, you can only use the types that you defined. So within the function, you can use .name without any problems, but you can't use .height because I didn't say there was a height of person. So this will be a type error. But when you're passing an object in, all you have to do is pass name and age, and you can pass extra things and Flow will ignore them because you're satisfying the minimum requirement, which is that this object needs to have name and age. This is a very common source of confusion, and the next thing will explain how you can get around it. In cases you don't want extra keys, like you want to have a requirement that you do not want to be able to pass extra keys in, there's this thing called exact object types, which just put little pipes around inside the curly brackets, and then both the lower and upper bound basically become the same, and now you can't pass in extra keys and it'll type error. There's also a utility type called $exact that I will point to in the end, which converts it for you, but I usually just use types. Read-only keys. Some of these examples are now a little contrived, but they're very useful in React and Redux when you want all your objects to be immutable. So especially like props, for example, you want to make all your prop types read-only so that you don't mutate your props within your React component, for example. So let's say you have, like, again, person. You can, like, rename that person in a function. Like, you can give this a person object, and this function can just mutate this object for you, and it's fine. But sometimes you want a guarantee that your function will not mutate your objects. All you need to do is put these little plus signs in front of keys. Remember how covariant things were kind of connected with immutability? The same thing kind of applies here. Plus sign means read-only, pretty much. So you can make an immutable person type, and if a function takes the immutable object version of it, then you can pass it the same object, and you will not be able to mutate that object within the function. There's also a write-only version. This is way more contrived. I have literally never used it, but it exists, so I thought I'd point it out to you. This is kind of common where you want to be able to set like default values or something like that. You want to be able to set a name. But you don't want this function to accidentally read any data, something to do with data privacy, which I don't know why anybody's ever done in JavaScript, but assume you have cases like that. You can make your types write only, where that function can write things to your object, but cannot read anything. And so in this case, you'll be able to write this fine, but when you try to read person.age, there'll be a type error because you're not allowed to read it. You can combine read and write together. Which is, let's say you have a function that takes a person and supposed to do some initial setup. You want a logging function. Yeah. I hope that was not for me. So a logging function, I guess that's a pretty good example of a function that should not mutate your object. Now, within this same function, you can just say, hey, I'm passing it an immutable version of my object. And you can just do that by doing this, because this type is a subtype of this type. Like, if you have this type, you can automatically just say it's this type and it's fine, because this allows both, right? So you say it's an immutable version, you pass it to log person, and if log person did any mutation, that would be a type error. Or if it required a mutable version of your object, that would be a type error. And then you can set default age, where you can say, hey, I don't care whatever this person's age is, just set it to be the default. And then this function can only write to this object, but can't read anything, and then you're good, and then you can return the person. I don't know, hopefully it makes sense. Okay, we've kind of reached the end. Utility types. Utility types are usually only used for libraries, and maybe like library-like functions that you sometimes write in your code base. Like higher order components use utility types. Things like getter and setter functions would use utility types. A few of them you would use more commonly, like $keys, which for enums, which I pointed to earlier. But here are a few of the most useful utility types. These are not all of them. There's way too many. Most of them will make no sense to you. You don't need them most of the time. So the first one is class. This is a pretty straightforward one, actually. This example is way longer, just so you can see an example of it. But as soon as you define a class, that name also becomes a type. So as soon as you have a class animal, whenever you say something is of type animal, it's an instance of that class. But sometimes you want the class itself. You don't want an instance of that class, you want the class itself. If you use Java, this is like the equivalent of : class, things like that. In Flow, you just use C class and put the class name inside of it, and you get the actual class, not an instance of that class. This is a slightly more advanced version of that thing, where you say, hey, this function will take a class which is a subclass of animal. So you say, I have some type which is a subtype of animal, and you will take the class of that subtype. And you're good to go. Next is $keys. Showed this earlier in the enums case. This just takes an object type, any object type, and gives you an enum of all the keys. That's all it does. It's very straightforward. So you have a person type, and you give it to $keys, you'll get name and age. You can also make it a more generic thing where you'll be like, hey, give me a person and give me a key of that person. And so you can just say, this is person, and the key will only be $keys person. So this is a much better type than just using string, which would let you pass in arbitrary strings which are not allowed. This way you can only pass in the strings that are actually keys of the object that you're asking for. So here there's a person object, I give it person and name, that's okay, but if I give it height, it'll be like, hey, person type doesn't have height, there'll be a type error. You'll notice this little colon mixed over here. Mixed is the union of all types. So it's like, I don't know what this type is. But that's not great. Like, you should be able to know that when I ask for a name, I should get a string. So the way you do that is this thing called element type. This is currently not documented anywhere. It's very new, but it is so useful that I thought I'd present it to you guys, because like, this is literally the feature I've been asking for the last 1 year. Not joking. TypeScript added it like a couple of months ago with like keys off and like square bracket syntax. This does basically the same thing. So this is how you use it. So you have a function, you say, I have some type k, which is one of the keys of person. And you're taking a person, you're taking a key, which is of type k, and you'll return element type person k. So you'll just go into that object, pull that particular key's value, and give you that type. And so now when you do like, hey, get value for key person and give it name, Flow already knows that name is of type string. Like, I put this thing here for you to see. You don't actually have to type it. Like, Flow will know that name is a string on its own. But again, when you do this is still an error because height is not one of the keys. But you can make it more generic. Like, why limit ourselves to person? Like, you have these methods like get, like _.get, things like that, which take an object and a key. So you can just say, I have some type O, which is some object. Like, this is how you say it's some object. All extra keys are subtypes of that type. And K is one of the keys of that object. Typo right here, this should be O. So you take an object O and key K, and then you get the element type from OK. Good to go. Okay, next thing, $exact. I kind of mentioned it earlier. If you don't want to use pipes all the time, you can just use $exact as well. So you have a normal object type, you don't want extra keys to be allowed, just wrap it with $exact. It's the same thing as doing this in the first place. Obj map. This is only ever used in libraries, really. This is like for functions that take one object and then like transform that object by mapping over all the values of the object and converting them to a different type. So in this example, thinking of a function that takes a normal object with actual values and returns an object with the same keys, but all the values have been replaced by functions that return that value. So for example, if you had like a person object with name, instead of just doing person.name, you'd have to do person.name paren to get that value instead. So how do you use it? You write a type of a function that would actually map it from the old value type to the new value type. So in this case, for any type t, the t gets converted into a function that takes no arguments and returns t. And then you just object map that object type with this function, and you get the new function type. And so now, when you have a variable of this person with getters type, you have to use .age paren to actually get the number. And if you use .age and don't put parentheses, you get this function type instead of just number. This is useful sometimes. You'll see it in libraries. It's probably not common in your own code though. There is a small catch with this function, this utility type, which is that it only implements that lower bound. Like, it implements how you can use it, but it does not implement what you can pass to it. So if I say this is some variable with person with getters and I try to pass some object into it, this is not the right type. It's supposed to be a function that returns a number, but Flow will not catch it because this is such an edge case, and because it's only for libraries really. That's why this does not get catched. There's a similar function called opt_map_I, which is literally the same method, but instead of mapping values to new value types, it maps keys to values. I've only ever seen one example of it, which I'll show in the next slide. In this case, the function I'm using is identity type. So it will take like any object and replace all values with the key itself. So now name will always be of type name and age will always be of type age. This is used for this function called key mirror, where you can like write all of these keys, and instead of repeating every key twice, you can just put like null or whatever, and this function will convert it for you, and the type will get applied the same way. I don't know why this is so useful. You can probably just type the keys, but Facebook uses it everywhere, and I've seen it elsewhere. People like to use it, so there. Tuple map is similar. Remember I mentioned like you can have tuples at the very beginning. You can also map over tuple types to convert each number into a function. This is the same like getter function that I used in the original thing. Instead of converting an object, we're converting a tuple instead. So this number gets converted into function that returns number, function that returns number. That's it. The same limitations apply to all three of these map functions. They will give you the correct usage types, but not what's required. You can still pass some random things to it, and it might not catch the type errors. $diff. I talked a lot about this in my previous talk. I have only ever used it for higher order components, but higher order components are literally impossible to type without it. So it's very useful. All it does is object subtraction. It takes two objects, subtracts the types of the second object from the first object, and you need that because usually in higher order components you're injecting some props. So whatever props you're injecting, you want to subtract those from your original props, and those are your new prop requirements. So if you see my earlier talk, there'll be a longer example of how to use it, but this is a simple explanation of it. There's a person type, there's just an aged type, like any object that has an age on it, and then you can like subtract aged from person, and you get this type back. Notice that age didn't go away completely, it's optional. So this only implements requirement, like the opposite of opt_map, so that the prop requirements are correctly generated. And this is because $diff was originally created for default props. So if you've ever used flow at all in your React code, or even if you have not used flow, you use TypeScript or something, you do know that your component has props and it may have default props. Within the component, all your props may not be optional. Like you can depend that every single prop that you define is there. You don't want to make them optional because you don't want to check for things that you know are guaranteed to be there. But you want to subtract those default props from your props to generate the prop requirements outside the component. I'll use this example. You have a person component. You expect name and age to always be there, but you have a default age. Like if the containing component does not pass you an age down, you will just default to like 10 or something. Within the component, you want name and age to always be considered there. You don't want to check that age is there or not. But outside the component, age should be optional. You should be able to not pass an age. This is why it becomes an optional key instead of being removed altogether. That's it.
Back there.
My question is, how is it different from TypeScript? Like, I see a lot of similarities now, like as compared to 2 years ago, Flow and TypeScript. So can you?
Okay, so the biggest difference is something I covered earlier, which was variance. So you know how these variance rules I explained to you, how by default an array type is invariant. So an array of dogs is not an array of animals because of mutation. TypeScript doesn't have that. So TypeScript will just let you make an array of dogs into an array of animals and push a cat into that array, and it won't type error, it'll be fine. And that's because Flow and TypeScript have very different approaches, like they have very different philosophies of what they're trying to accomplish. So Flow goes for correctness every single time. Like Flow is the most correct type system for JavaScript today. Yeah. Unless you count like Elm and stuff like that, which are not JavaScript. TypeScript doesn't care about being correct, it tries to be nice. So TypeScript has better tooling right now, it has better refactoring tools. It's slightly faster for autocomplete. It will do key completion, things like that. But it may have type errors because by design, they never tried to have a sound type system. That said, Flow also has a few issues right now, like with soundness. There's an any type that I did not talk about in this whole thing, which just means anything. It's both a subtype of all types and a supertype of all types. It's like a little hole to get away from types altogether. Flow is going to add more features to like even check for that. So it's like if you have anything that's implicitly, like you imported something from a file that did not have types, they all come in as any right now. That kind of take away the trust from all the types that you are using in that file. So the Flow team works on things like that. It's like how can we make sure that any goes away, things like that. And TypeScript goes for like how do we make it most nice to use. Another thing is there's some more features. So the utility types is a feature exclusive to Flow. And so TypeScript adds some features, so you can do the element type kind of stuff, but lots of other things are missing. And there's existential type, which is a star symbol, because Flow is a little better at inferring types than TypeScript.
Any other questions for Naman? Radical. Give him a round of applause. That was awesome. Sorry, too soon again.
Take applause.
Third time tonight.
Hi, my question is, you're mentioning about higher kind of types support, but typically in languages like Haskell, where the type system provides capabilities for that, so how you are able to achieve that in Flow? And when you transpile the code to JavaScript, I just want to know how it is possible.
So when I studied higher kind of types, so full transparency, I'm not on the Flow team. I've written docs for them, but I'm not on their team. So there's a few different ways people understand higher kind of types. Some people just think of this as a higher kind of type, which is any type that uses a generic type within it. So obviously Flow supports that. In terms of like other higher kind of types, like utility types utility types are almost like functions for types. They take types and return types. So I kind of call them higher kind of types. But there's like, from what I saw in like other docs that have been trying to learn functional languages, Flow mostly supports higher kind of types as is. The only thing that Flow currently doesn't support fully is like functions with arbitrary length types. Like you want a generic t, but you don't want one t. You want an arbitrary number of t's. And you can sometimes do it, but not other times. I was considering putting that in this talk, but it didn't quite fit in under any topic, so I skipped it. I can talk to you afterwards. All right.
Okay. This time for sure, round of applause. If you guys have any follow-up questions or anything, I'm super approachable on Twitter. He's there all the time.
I will also tweet this link, so these slides are online right now.
Yeah, we'll try to get these, the edited slides and the video content up ASAP. But thanks so much to all of the awesome women at Walmart Labs who helped put together this meetup tonight. And thanks to Joel and Ron and Naman for speaking. That's awesome. Next month we're at Reddit, so remember to RSVP early for that guy. And thank you guys so much for coming tonight. I hope you have an awesome evening.